Welcome to CIE Math Solutions. In this video, we will continue the series of math tutorial videos about sequences and series. In today's video, we will learn one of the ways of finding the specific terms of an arithmetic progression or arithmetic sequence given any two of its terms. Welcome to another video of CIE Math Solutions. In the previous videos, we have already discussed the process of finding the specific term of an arithmetic sequence given its general rule. Also, we have already discussed finding the specific term using its first three terms. The playlist containing these videos, together with other math tutorial videos on sequences and series, are found in the link above this video or in the description below. If you are new to this channel, please consider subscribing and don't forget to hit the bell icon for you to be notified when new videos are uploaded. If you have already subscribed, please watch, like and share the videos of the channel. Thank you. In this video, we will focus on finding the specific terms of an arithmetic sequence or arithmetic progression given any two of its terms, using elimination method of solving simultaneous equations. But before we proceed, let us have a quick recall of the prerequisite concepts needed. First are the basic concepts of arithmetic sequence or arithmetic progression. Second, the nth term or general rule of an arithmetic sequence. Third, solving simultaneous equations. For the first prerequisite concept, the basic concepts of arithmetic sequence, for a given arithmetic sequence with terms 12, 20, and 28, these terms are denoted by an. In this sequence then, a1 is equal to 12. A2 is equal to 20, and A3, which is the third term, is equal to 28. The common difference of an arithmetic sequence is denoted by D. D here will then be 28 minus 20, or 20 minus 12, which are both equal to 8. The common difference then, or the value of D for this arithmetic sequence, is equal to 8. If you would like to learn and practice more on the basic concepts of arithmetic sequence or progression, you may click on the link above this video or on the description below. The next prerequisite concept needed is the nth term of an arithmetic sequence, which is an equals a1 plus n minus 1 times d. An here is the nth term of the arithmetic sequence. A1 is the first term, n is the rank or order of the terms, and d is the common difference. If you are interested in the derivation of this formula, you may click on the link above this video or on the description below. The last prerequisite concept needed is solving simultaneous equations. For example, solve the following simultaneous equations. X plus 3y is equal to 24. X plus y is equal to 10. Solving simultaneous equations means that we are trying to find the values of the variables, in this case, x and y, that satisfies both equations. Our first goal then is to make sure that the coefficients of one of the variables are equal, so we can easily eliminate them. In this case, the coefficient of x in the first equation is 1. The coefficient of x on the second equation is 1 also. That means we can now directly subtract these two equations. If we do that, x minus x will then be 0x. 3y minus y will be 2y. 24 minus 10 is equal to 14. Simplifying, we will then have 2y is equal to 14. Dividing both sides by 2, we will then have y equals 7. The value of y then is 7. To find the value of x, we will just substitute the value of y that we got to any of the two equations. I would recommend to substitute it on the simpler equation or the equation with smaller coefficient. In this case, the second equation is simpler, which is x plus y is equal to 10. Substitute 7 to the value of y. That will give us x plus 7 equals 10. X then is 10 minus 7, which is now equal to 3. The solutions then to the simultaneous equations are x equals 3 and y equals 7. Now let us use these prerequisites in finding the specific terms of an arithmetic sequence given any two of its terms. For example, the 5th and 13th terms of an arithmetic sequence or progression are 38 and 94 respectively. Find A8 or the 8th term, A15 or the 15th term, A40 or the 40th term. Before we could find the specific terms, let us find first the common difference and the first term of the arithmetic sequence. To do that, we need to represent each of the given terms using the nth term of an arithmetic sequence, which is an equals a1 plus n minus 1 times d. The 13th term then of this sequence which is given is equal to 94. That is, a13 is equal to 94. The 5th term, which is equal to 38, can be represented as a5 or a sub 5 is equal to 38. Using now the nth term or the nth term formula of an arithmetic sequence, a13 now could be rewritten as 94 is equal to a1 plus 13 minus 1 times d. Simplifying this equation, we will then have 94 equals a1 plus 12d. Take note that the 13 here, which is the value of n, is the rank of the given term, a13. For the second given term, which is a5, the value of n here is equal to 5. That means 38 is equal to a1 plus 5 minus 1 times d. Simplifying this equation will be 38 equals a1 plus 4d. Let us now solve these simultaneous equations to find the value of a1 and d. Subtracting these two equations, we then have 94 minus 38 is 56. That will be equal to a1 minus a1 will then be 0. 12d minus 4d will be equal to 8d. Dividing both sides by 8, we will then have 56 divided by 8 is equal to 7, and 8d divided by 8 is equal to d. The value then of d is equal to 7. To find the value of a1, we will use the second equation and substitute the value of d that we got, which is equal to 7. We will then have 38 equals a1 plus 4d. Substituting the value of d, 38 is equal to a1 plus 4 times 7. 38 then is equal to a1 plus 28. a1 then is 38 minus 28, which is equal to 10. Now let us find the general rule for the given arithmetic sequence or progression using a1, which is equal to 10, and d, which is equal to 7. an is equal to a1 plus n minus 1 times d. Substituting the values a1 and d, we will then have an is equal to 10 plus n minus 1 times 7. Distributing the 7 to n minus 1, we will then have 10 plus 7n minus 7. Simplifying this further, an is equal to 7n plus 3. This is now the general rule for the given arithmetic sequence. Upon finding this general rule, we can now find the specific terms of the arithmetic sequence. For this item, a8, the value of n here is equal to 8. Substituting 8 on the n of the general rule, we will then have a8 is equal to 7 times 8 plus 3, which is equal to 56 plus 3. The 8th term then is equal to 59. We will use another method in finding this term. Instead of using the general rule, we can also substitute the values on nth term of the arithmetic sequence. Using n equals 8, a1 equals 10, and d equals 7. So in this nth term formula, we then have a8 is equal to 10 plus 8 minus 1 times 7. Simplifying further, that will give us 10 plus 49. 10 plus 49, the 8th term is equal to 59. The value is still the same as the value that we got in the previous method. You may choose either of the two methods since both of them will give the same answer. For the second item, which is A15 or the 15th term, the value of n here is equal to 15. Substituting this value of n in the general rule of the arithmetic sequence, we then have A15 is equal to 7 times 15 plus 3, which is equal to 105 plus 3. The 15th term of the arithmetic sequence then is equal to 108. Using the second method, we have n equals 15, a1 is equal to 10, and d is equal to 7. Substituting the values, we then have 10 plus 15 minus 1 times 7. That is equal to 10 plus 98. The 15th term then of this arithmetic sequence is 108. The last item is A40, which is the 40th term. The value of n here is equal to 40. We then have 7 times 40 plus 3, which is 280 plus 3. That is equal to 283. Using the second method, we then have the n to be equal to 40, a1 is equal to 10, and d is equal to 7. Our 40th term then is 10 plus 40 minus 1 times 7, which is equal to 10 plus 273. The 40th term is 283. To summarize the answers of the items, we then have A8 or the 8th term is equal to 59, A15 is equal to 108, and A40 is equal to 283. Now it's your turn. The 8th and 17th term of an arithmetic sequence or progression are 52 and 88 respectively. Find A5 or the 5th term, A12 or the 12th term, A28 or the 20th term, A42 or the 42nd term. If you would like to try to answer this item, please pause the video for a while, and when you are done, press the play button to check your answers. Now let us have the answers. Representing each of the given terms using the nth term of an arithmetic sequence, an equals a1 plus n minus 1 times d, we will then have a17 or the 17th term is equal to 88, and also a8 is equal to 52. A17 equals 88 then can be rewritten as 88 equals a1 plus 17 minus 1 times d. Again, the 17 is the value of n. Simplifying it further, 88 is equal to a1 plus 16d. The same case for the second one, 52 is equal to a1 plus 8 minus 1 times d, which is 52 equals a1 plus 7d. Solving these simultaneous equations, we will then have 88 minus 52 is equal to 36. 16 minus 7d is equal to 9d. Dividing both sides by 9, we will then have the value of d, which is equal to 4. To find the value of a1, we will use the second equation. 52 equals a1 plus 7d. The value of d here is equal to 4, so the equation then becomes 52 is equal to a1 plus 7 times 4. 52 is equal to a1 plus 28, multiplying 7 times 4. That will give us then the value of A1, 52 minus 28, which is equal to 24. We can now find the general rule of the arithmetic sequence using the values of A1, which is 24, and value of D, which is 4. We will then have AN is equal to 24 plus n minus 1 times 4. Simplifying this further, the general rule then of this arithmetic sequence is 4n plus 20. We can now use this general rule to find the specific terms of the arithmetic sequence or progression. For the first item, A5, the value of n here is equal to 5. We will then have 4 times 5 plus 20, which is equal to 40. The fifth term then is equal to 40. Let us check with the second method. In the second method, the value of n is equal to 5. The first term is still 24 and the common difference is still 4. We will then have A5 is equal to 24 plus 5 minus 1 times 4, which is 24 plus 16. A5 is equal to 40. For the second item, which is A12, or the 12th term, the value of n is equal to 12. Substituting these on the general rule, we will then have 4 times 12 plus 20, which is equal to 48 plus 20. That means our 12th term is equal to 68. Using the second method, we will then have A12 is equal to 24 plus 12 minus 1 times 4. Simplifying this will give us 24 plus 44, which is still equal to 68. The third term is A28, or the 28th term. We will then have A28 is equal to 4 times 28 plus 20. That is equal to 112 plus 20, which will give us 132. Verifying this with the second method, we will then have A28 is equal to 24, which is the first term, plus 28 minus 1 times 4, which will give us the value of 132. For the last item, which is A42, the value of n is 42. Substituting it on the general rule, we will then have 4 times 42 plus 20, which is equal to 168 plus 20, which gives us the answer of 188. Again, let us verify with the second method. A42 is 24 plus 42 minus 1 times 4. The value then that we got for the 42nd term is 188. Summarizing the answers of these 4 items. A5 is equal to 40. A12 is equal to 68. A28 is equal to 132. And A42 is equal to 188. If you got all the answers correct, then congratulations! You now know how to find the specific terms of an arithmetic sequence or progression given any two of its terms. If you did not get all of the items correct, don't worry. You can still practice more. You may answer the following homework. The 4th term and 21st term of an arithmetic sequence or progression are 7 and negative 95 respectively. Find A15 or the 15th term, A26 or the 26th term, A63 or the 63rd term. If you would like to check if your answers are correct, you may type them in the comment section below. I will soon reply to your comment, verifying your answers. In summary, for this method, to find the specific terms of an arithmetic sequence or progression, given any two of its terms. First, find the equation representing each of the given terms using the n-term formula. Second, solve the simultaneous equations. That will give you the value of A1 or the first term and D, which is the common difference. Third, formulate the general rule for the arithmetic sequence. And fourth, substitute the order of the specified terms as the value of n in the general rule. Thank you for watching this video. For more videos on math proofs and derivations, math tutorial videos, solve items from international exams, math tricks and puzzles, math resources, and more, please don't forget to watch, like, subscribe, and share. Thank you for your continued support to CIE Math Solutions.